Imagine if we could hear the sun? Nature can be really quiet or really loud. It can even be musical. We hear sound almost everywhere on Earth. But what about sounds from space? Despite what you might hear in science fiction movies, you can't hear any sound in space. But imagine if we found a way to listen to the stars, especially our sun? Even though we can't hear it, since sound doesn't travel through the vacuum of space, the sun is incredibly loud. The immense power emanating from its core produces sonic waves that travel and bounce around inside it. Scientists aren't exactly sure how loud the sun is, but they estimate that there would be at least 200 watts of sound power for every square meter, 1.2 square yards. This would be equivalent to 329 decibels, which is so loud that it would kill you. Think of it being like an opera singer shattering a glass. But in this case, you're the glass. Our atmosphere here on Earth provides a medium for sound waves to be heard. If a crow caws or a cat meows, these sound waves produce vibrations in the air molecules around us, forming frequencies that vibrate in our eardrums. Even though space lacks an atmosphere to transmit sound, there are still particles within the plasma of space that can be affected by sound. These ripples of energy are known as like sound. They are pressure waves, but they're also magnetic. They're also very small and quiet, around -100 decibels. To put this into perspective, a normal conversation is about 60 decibels. So, we would need eardrums the size of Earth to hear these waves. Okay, so maybe having giant eardrums isn't the best way to listen to the sun. So how else could we hear it? Immense clouds of hot gas rising from inside the sun, and traveling at speeds over produce ripples on the sun's surface. And if you've ever passed gas yourself, you know that other people can hear it. So you won't be surprised that all that gas makes the sun noisy too. But since we can't hear it, how can we measure it? The sonic ripples on the sun's surface cause changes in the frequency of light, giving scientists an accurate picture of what is going on within the sun. Scientists can measure these light frequencies and translate them into sound waves. This process of turning information into sound is called just as an ambulance's siren changes pitch as it passes by us. The frequencies of light rippling across the sun change color, based on the direction and speed they're moving at. For instance, if the sun's ripples move away from us, they stretch out and give off a reddish hue. If they move toward us, they become bunched up and bluish in color. With so much movement and activity on the surface of the sun, it vibrates at many different frequencies. Using a computer, scientists can translate the motion of the sun's light waves into sound waves, which are then sped up so that humans can hear them. This produces a sound similar to church bells hitting several notes simultaneously. As frequencies overlap and mush together, they create rhythmic bass thumps over a constant background hum. It's kind of like a heartbeat near a refrigerator. So imagine if we could actually hear the sun with our own ears? Hypothetically, if space had an atmosphere like ours, how loud would the sun be here on Earth? Due to the inverse square law, the sun's sound would travel outward in all directions, meaning that the surface area of the sun's sound would get larger and larger as it emanates outward. But the number of watts per square meter when the sound reaches Earth would be reduced to just this is the equivalent of 90 decibels, or the sound of a motorcycle engine right by your face. It would feel like being at a loud rock concert, all the time. You'd probably want to invest in some good earbuds.